periods, we have been looking at function notation and how to do transformations. Today what we're going to look at is we're going to look more closely at linear functions. So our big question for today is how can you use a linear function to model and analyze real-life situations? So some core concepts that you will need to know is you will need to know the three basic forms for writing an equation. The first one being slope-intercept, y equals mx plus b. This second one, if you're given a point and a slope, we can use what's called point-slope form. And the third point value is when you're given two ordered pairs. Now, as a reminder also, slope is considered by the calculation as the change in your y's over the change in your x's. So we might have to do a little computation to figure this out. Okay, so quick review before we start what we're going to do today. I want to go over the three methods for writing an equation. Okay, the first one, write an equation given the slope and y-intercept. Well, when you're given the slope and y-intercept, the easiest form to put it in is slope-intercept forms, which is y equals mx plus b. To do so, all you do is where you see m, which is your movement, you're going to put the 7 in. And when you see the y-intercept, you're going to put that in for your beginning value for your b. So it's y equals 7x plus 3. And that's it. Pretty straightforward. For the second example, I'm giving you a slope and a point. Now there's two different ways you can do this. You could use point-slope formula, or you can use y equals mx plus b. I'm going to kind of show you both ways, and you decide what works best for you. So the first method I'm going to use is point-slope formula. So it says y minus the y value in our ordered pair. So minus a negative 3 equals m, which is 7 in this case, parentheses, x minus the x value in the ordered pair. Now I like this method because there's not a whole lot of thinking to do and resubstituting back in. You just simplify and solve for y. Minus and negative is the same as a positive, so it's y plus 3 equals, we distribute the value, 7x minus 28. And then our last step is to subtract 3 over. If I'm at negative 28 on a number line and I subtract 3 more, that is going to put me at negative 31. Well, you might be saying to yourself, Mrs. Dorn, that seems like a lot of work. Is there an easier way? Well, some people like to use just plain old y equals mx plus b. You will get the same answer. Sometimes people like it, sometimes people don't. Okay, so we plug in what we know. Our y value is negative 3. Our m is 7. Our x is 4. But I don't know my b, so plus b. Well, I get negative 3 equals 28 plus b. And then to solve for b, I have to use my inverse, so I'm going to subtract 28 over, which gives me negative 31 equals b. Now this is why I don't like this method so much, because then I have to remember, hey, I'm not done. That's not my answer. My answer is taking my information and plugging it back in. So y equals, my slope is 7, x, and now I can put my b in, negative 31. The benefit of using point-slope formula is that it's already all done for you. You don't have to worry about it. Okay, the third method is given two ordered pairs. No matter which part you use or which method you use, you have to always find the slope first. Now some people like to use point-slope formula to find the slope, but I just like our basic slope equation. y2 minus y1 over x2 minus x1. And if you like it y1 minus y2 over x1 minus x2, that's fine. The idea is that you keep the same order when you're calculating the answer. So for mine, I'm going to take y2 minus y1. So 9 minus a negative 7. Minusing a negative 7 is the same thing as adding 7 on top. On my denominator, I'm going to take 5 minus 3. So on top, I have 9 plus 7, which is 16. 5 minus 3, which is 2. And 16 divided by 2 is 8. Now I can use either method to write my equation. So I'll show you both methods once again. So if I do just slope-intercept, y equals mx plus b, it does not matter which ordered pair you pick. I always tend to like the ones more that have no negatives in them. So if that's possible, I'm going to plug in 9 for my y. My m is 8. My x is 5. So 8 times 5 is 40. To get rid of a positive 40, I subtract it over. If I'm at 9 and I subtract 40, I'm going to be at negative 31. So my equation is y equals my slope, which was 8, x, and then my y-intercept, which is negative 31. Change it up. I'll go ahead and show the other method as well. So point-slope formula, y minus my y value, which is 9, equals my m, which is 8, times x minus my x value, 5. Get y minus 9 equals 8x minus 40 because we distribute. I add 9 over and it automatically gives me my equation. Y equals 8x minus 31. Do I require that you show me both methods? No. But I want you to pick one that works for you. So that's a review of how to write an equation given a slope and a point, a slope and an intercept, and 2 order pairs. So what we're going to do now is we're going to actually apply this information. So example 4, I have this diagram for you. It states, the graph shows the distance asteroid 2012 DA14 travels in x seconds. Write an equation of the line and interpret the slope. The asteroid came within 17,200 miles of the Earth in February 2013. But how long does it take the asteroid to travel that distance? Okay, so first thing we need to do is we need to write ourselves an equation. Now this is a great review of reading a graph. You first need to start by looking at your graph and saying, oh, I'm time versus distance. I need to find my y-intercept. In this case, it is 0. 0. Okay, now I need to find a value that's easy to read on my graph, which is 524. Now you can use your equation, y2 minus y1 over x2 minus x1, or you could do rise over 1. Well, we rose 24 miles. In 5 seconds. Now 5 goes into 24 4 times. Okay, so and that leaves you 4/5 left over, which is 0.8. So I'm just going to convert it to 0.8 so we can use our calculators and help us find answers. So now I need to write my equation. Y equals my slope, 4.8. X, and it starts at 0, which you could put 0 in here or you do not have to. The reason it starts at a time 0 and has a distance of 0 is because nothing's happened yet. It won't always be 0, 0. So we need to interpret the slope. So you could either say it goes 24 miles in 5 seconds, or you could create the unit rate and you could say it goes 4.8 miles per second. It's pretty fast. That is what interpreting the slope means. Goes 4.8 miles per second. It is increasing because you are going further. It says the asteroid came within 17,200 miles in February 2013. About how long does it take the asteroid to travel that distance? Okay, so if this is my equation, and my miles is my y, I'm going to plug in 17,200 for my y value, and I'm going to solve for my x by using inverse operations. And this is why I converted it to a decimal, because it was a terminating decimal, which means it's easy to solve and put in decimal form. We don't have to round. If I divide both sides by 4.8, I get 17,200 divided by 4.8, which yields a value of this, 3,583.3 repeating, which remember that's the same as 1/3. It said about how long did it take the asteroid to travel that distance. So it took 3,583 seconds. Now if you were to try to convert that, okay, we know that there are 60 seconds in a minute, so if we divide it by 60, that will give us our minutes. It only takes 59 minutes, 59.72 repeating, which is only about an hour. So it would have only taken it an hour to hit us, or to travel that distance. Okay, the next question, example 5. Car loans, that's something everybody's going to have at some point unless they fork over the cash at the beginning. It says the graph shows the remaining balance of your car loan after X months. Okay, realize it's saying in thousands for our money. Write an equation of the line and interpret the slope and y-intercept. Okay, what is the remaining balance after 36 months? So if we look at this, our line is decreasing because it should be. As we pay off our loan, we should have less. If we look, our y-intercept is 0.18. And we have another value they give me at 10.15. So to start with, I'm going to calculate my slope. Now you can do rise over run and figure that out if you want, but I'll just calculate it this time. I'm going to do 18 minus 15 over 0 minus 10. Now you could have done 15 minus 18 over 10 minus 0, and you'll get the same answer when it reduces. You get 3, so you get negative 3/10 or negative 0.3 repeating. Not repeating. I goofed on that. Just negative 0.3. Okay, so now I'm going to write my equation. Y equals my slope. So you could use either form in this case because we're analyzing, so negative 0.3 x, and it began at 18. Okay, we got to remember that is in thousands though. That is in thousands. It says interpret what the slope means. Okay? So it is thousands per payments, 10 payments. So you're going to lose 3,000 for every 10 payments. Okay? You're going to lose 3,000 per every 10 payments. Or you could say you're going to pay off 3,000 every 10 months. I'm a horrible speller, FYI. Okay? 3,000 every 10 months, or you're basically paying off 3/10 every month. $0.3 every month. So about $333 every month. Okay. Now it says interpret the y-intercept. Well, the y-intercept says at 0 months we're at 18. So the total cost of the vehicle is $18,000. You can buy yourself a halfway decent new or used vehicle at that price. And ask, what is the remaining balance after 36? So if I look on my graph, 35 is about right here, so we know it's somewhere above 6. So 36 months, 36 would be my x value, so I'm going to take my equation, y equals negative 0.3 times, and I'm going to put 36 in, plus 18. It is going to yield for me the cost of what I have left to pay. Which is 7.2. Well, 7.2 what? Well, that is $7,200. 36 months is 3 years. So after 3 years, all I have left to owe on my car is $7,200. Okay, example 6. I promised that I liked examples. Now this is going to change things up for you. It's going to have you give you tables. It says 2 prom venues charge a rental fee plus a fee per student. The table shows the total costs for different numbers of students at Lakeside Inn. The total cost Y in dollars for X students at Sunview Resort is represented by the equation. So this is Sunview. And this is Lakeside over here. Okay, it asks, which venue charges less per student? How many students must attend for the total cost to be the same? Okay, well, we have a question here, and we know already if you look at this. If you look, analyze what this means. The value in front of our x is a rate. So this tells me that this costs $10 per student plus a flat fee of $600 for the venue. Okay? This one over here, well, we have no idea. They don't charge a flat fee. They just charge by the number of people. So if I take 1,500 divided by 100, I get $15. If I take 1,800 divided by 125, I get 14.4. If I get 150, 2,100 divided by 150, I get $14. If I do 175, I get 13.7. If I do 2,700 and I divide it by 200, I get 13.5. So theirs is a little bit different. Question is, which venue charges more per student? Okay, remember, the other company doesn't charge for a flat fee. Well, this venue here charges $10 per student for any number. This one goes anywhere from 13 to 15 depending on which person. Well, let's think about this. Where is it going to be the best? How many students must attend for the total cost to be the same? Okay. Which venue charges less per student? Well, if we look at this, this one overall charges less per student, which is Sunview. Sunview charges less per student. Makes sense. But what we're trying to do is we're trying to figure out where they're the same. Where is the value going to be the same? At what value am I going to have exactly the same amount of cost? Well, you have a couple options. You could plot them all and draw some lines and figure out where they connect. we can kind of plug in some numbers. Okay, if I say I plug in 100, make a table if you want. I'm going to plug in 100. Say I look at 100 students. Add 600 to it. Well, let's see. That's going to be 1,000 plus 6, so that's going to be 1,600. So right now, Lakeside looks like it's doing better. Well, let's try 125 students. 10 times 125 is 1,250. Plus 600 is, I believe, 1,850. Well, we're getting closer. Let's try 150. 10 times 150 is 1,500. Plus 600 gives me $21,000, or excuse me, $2,100. That'd be an awful expensive venue otherwise. Well, I found the match. The match is at 150 students. So it looks like before 150 students, it's actually cheaper for you to go with Lakeside, because it's giving you, or excuse me, to go with Sunview, because overall it's giving you, excuse me, I can't even think, Lakeside would be cheaper. But who's to say what's going to happen after that point in time? After that 150 students, you'd have to plug in some additional numbers and see. For example, if you wanted to do 200 students, well, that'd be 2,000 plus 600. That'd give me $2,600. So this is the breaking point. 150 is the breaking point. After that point, Sunview is cheaper. Sure, it looks like it's cheaper per person up front, but unless you're going to have 150 people or more, it's actually not the cheaper of the two bids. Okay. To finish up, we need to hit line of best fits, because not all of our data always creates a line. So what we're going to do is we're going to create a scatter plot of data. Now you can do this by hand, which is what you did in Algebra 1. Or you can use the online desmos, which is what we're going to do. Sketch a line that most closely appears to follow the trend given by the points. We're going to pick 2 points on that line and estimate the coordinates of each point. And then we're going to write an equation of the line that passes through them to get our model. Okay, for the last example, we're going to actually look at femur lengths versus height of people, several people. If you look here, they measured the femur lengths of several people and their actual heights. Okay, it is in centimeters. Does the data show a linear relationship? Well, the easy way to look at this is that kind of you put them in order visually or thinking about, are they both increasing? Well, it looks, as my numbers increase on the left, my numbers tend to increase on the right. So yeah, it's probably a linear relationship. So does it make a linear relationship? Sure it does. As one value is increasing, the other one is too. If so, write an equation of a line of best fits and use it to estimate the height. Okay, so to do so, what we're going to do is we're going to go to Desmos. Now you can do this by hand, but for this activity online, just so I can show you how this works, we're going to do this on Desmos. So you go into desmos.com, you go to calculator, you go down to the drop menu next to number 1 and you select a table. And you enter in all this information. It will look something like this. Okay? Then what it will do is on the graph, it will plot it. Now you're going to have to zoom in or zoom out to find that graph. And it looks something like this. So this is just a little snapshot of the data. If you look, it's pretty linear. It's pretty much a really strong correlation because they're really close together. Okay. Now at this point, we could draw a line through the data and figure out a bunch of information, pick 2 points on that line, do all that fun stuff. Remembering from Algebra 1, a line of best fits does not have to go through 0, 0. You just want about the same amount of points above and below the line. Well, it looks like it's going to hit at about 0 and about 115. Okay? What we would do is we would just normally pick 2 points on the line. Doesn't matter which two, you kind of want them not close together. Okay, so this one looks pretty good and this one looks pretty good. And what you're going to do is you would calculate your slope and write your equation. But what you also need to be able to do is do this on a calculator. So in order to do this, we're going to estimate the height of a 35-inch femur that's 35 inches tall. So to do this, what you're going to do is in equation, or the second box down on your left, you're going to type this in. And the way in which you type this in is you do y underscore, and we're going to put a 1 there. Reason being, it's going to refer back to the table. We're going to do the similarity. We're going to do m, then you do x, your underscore and your 1, and then plus b. What it's going to do is it's going to take that table and it is going to create the line for you. Now here is a line that was given for me. Now this line is better fit for the data. Okay, so if you look at this, it says, and Mars' graph was a little bit off when we were trying to estimate. It probably wasn't the best of ideas to do it that way. Okay, it's got my lovely regression, how close it is. If you look, this is approximately what my equation says it's going to be. 2.6 times x plus 65, where x is the length of the femur. Now all I would have to do is take that and plug in my femur length, which I believe was a 35.